Thanks for coming, everyone. I know yesterday was the party, so I appreciate you coming here this morning today. My name is Atta. I'm from LWA Solutions, and I'm joined today by my colleague Mahmoud.
Hello.
And we'll be doing a joint presentation on LWA's journey delivering cross-platform Xamarin apps. So earlier this year, we delivered a solution for the Middle East's largest courier company. And this solution essentially replicated functionality that was found on $1,500 scanners put onto low-end smartphones. And so today's session, we're pretty much going to talk about the journey and some of the learnings that we picked up along the way as we delivered this solution. So essentially, our session today is going to be split up into two parts. The first part I'm going to take, which is about the design and some of the design considerations that we took and some of the learnings that we went along the way. And the second part will be taken by Mahmoud, and he'll be deep diving into some of the technical learnings that we had as we delivered it in Xamarin. So I'll kick straight into it. Initially, I'll talk about the challenge that we had and some of the design thought that went into how are we going to get this functionality onto a $200 smartphone and how are we going to prove that we could actually achieve this. The second was, once we did achieve that proof of concept, why we went with Xamarin and why Xamarin sort of made sense for this particular customer and this particular solution. And then finally, I'll touch on some of the design considerations and how we went about actually designing that cross-platform Xamarin app. Right, so for those who aren't familiar with RMX, RMX is the largest courier company in the Middle East. They've got 12,000 offices, 33,000 vehicles, 66,000 employees, and they're servicing over 240 countries. Basically, they've recently acquired Fastway, so they're actually now relevant more in Australasia. When we first met with their CIO just about 2 years ago, he had a really ambitious vision, and he wanted to bring all that functionality that was found on these scanners onto the low-end smartphones. But he had quite a clear goal. He said, look, I want this functionality on something that costs no more than $200. And so this also kind of eliminated this idea of having a Bluetooth peripheral or a scan head or something like that. And yeah, we were very confident in being able to build apps at the time, and we thought, yep, theoretically we should be able to do it. Why not? We'll give it a crack. The challenge, I guess, that we were initially faced with, as I said, we were confident in our ability to develop apps and design apps, but we had never touched anything in the logistics industry before. We'd never done anything in the courier business, and so when they gave us all of these spec sheets and these spec documents, they might as well have been written in sort of Swahili or something because it was very foreign to us, right? And so how we approached that is we took a very heavy UX and design-led approach when we were brainstorming how to deliver this. So as you can see here is a Windows CE solution. And we were going to be taking this on from a CE solution to a Windows Phone, completely different input mechanisms. It's touch-based and that sort of thing. So we needed to figure out how we're going to tackle it. So essentially what I did and what my design team did is we spent 2 weeks as courier drivers. And we actually literally put on our RMX kit, went out there and started delivering packages with these guys because I wanted to actually see what was the real world, what was their day-to-day experience like, where were the inefficiencies in the existing system, and what were the constraints that we're going to hit when we're going to go from a ruggedized scanner to a low-end smartphone. Obviously, it's obvious when you look at it in hindsight, but scanning is really, really important for courier drivers. But not so much that. The efficiency of scanning and the efficiency of an infrared scanner was critical to their day. And so immediately we knew that that was going to be really, really important to get exactly right. One thing that I didn't think about when I was speaking to their CIO initially, I thought, yeah, barcode scanning can be done via cameras, no problem, SDKs are there. But when I actually went on the field and started delivering packages with these courier drivers, you look at the package and there's a reflective surface on that. And so trying to hit that barcode using a camera pixel-based scanner was very challenging. So immediately when I thought, okay, this is going to be a bit of a problem, we're going to have to figure out how we're going to get around this. Some of the positive things that I've noticed as well is they're actually using multiple devices to get their tasks done. So they had a phone, they had a GPS unit, and they also had a scanner. So potentially, if we consolidated into one piece of hardware, we could look at efficiencies other way. Because I knew that we're never going to get, I'm not going to come up here and say that we got the same efficiency as on a camera that we did on an infrared scanner. But potentially, with good UX and good design, we were able to draw other efficiencies to make the overall experience of that courier driver a bit better. So sure enough, after we did a couple of weeks with the couriers and looked at these problems and saw where these challenges were going to be, we started to brainstorm and sketch up and figure out how are we actually going to design this solution and draw these efficiencies that were going to make us at least get on parity with the efficiency of an infrared scan head. So as I said, scanning was really important. So we did things to try and make the overall experience quicker. We weren't going to be the same speed as an infrared, so what we did is we did the smarts around the actual experience. One of these things, for example, when you scanned a barcode for a particular customer, and that customer had other packages, the UI would actually tell them, hey, would you like to add these 3 or 4 other packages to the delivery without actually having to scan it? We did other things like constant auto scanning, so as soon as the courier would tap on the screen, it would constantly try and pick up using the camera so that the courier could sort of orient and get that reflection just right. Grayscaled the background, so it's very easy to see where the red line is and where the reading is maximized. And other sort of little UX type efficiencies to get that experience better. The other really important thing for courier drivers is actually capturing signatures. So we knew that the app had to scan really well and had to capture signatures really well. We tried and took it to the next level as well in the whole customer experience. That the only touch point with the customer for this app was when they're going to take a signature. So if we made that experience really delightful for the customer, not only are we going to increase the fidelity of the signature from a legal perspective, but it also feels nice when they're capturing that signature. So we put a lot of effort into designing that, how you capture the signature. And finally, like I said, we took a very heavy design-led approach. We wanted to bring it onto the low-end smartphone. We wanted to make it intuitive. We wanted the courier to adopt this solution. How many solutions have we seen in the enterprise industry where a tech solution comes out, we throw it onto the user, and the user just use it, train them. They can learn it. We wanted to take the approach of they actually wanted to use the solution as opposed to they had to. And so we treated the courier as a consumer. We took a consumerized approach to delivering this solution. And so hopefully you can see in that screenshot there that the app looks clean, looks tidy, looks like something you'd expect from any store. So the power of a $200 smartphone actually was, as I said, they were carrying a GPS unit, a ruggedized scanner, a personal phone. When we consolidated all of these features into the single device, you were able to do some interesting increases in efficiency. So we had one-click calling, one-click routing to the customer, and that sort of thing. Was that sliding over? Okay, great. So we were very fortunate when we actually rolled out that first proof of concept solution, and they started giving it to couriers, and actually rolled it out in India first. And they found that initially it was kind of the IT pet project that was kind of hidden away from the business, and operations didn't really know about it. And when the Indian operations started to order more and more and more of the devices, they started saying, well, what's going on? Do we actually have an app to deliver packages? And it gained a lot of momentum, and now we actually saw that, yes, it is possible. We were able to replicate that functionality, and so now the business started getting a lot more serious about it, and they wanted to, I guess, deliver a more effective mobile strategy. And what they wanted is basically, they wanted now a hybrid BYOD solution. They wanted for their heavy usage couriers, they would give them the scanners, but they also wanted the ability to scale their business so that part-time or temp staff or onboarding over Christmas or something like that, they could get anybody to just pick up their phone and start delivering packages. Now this meant that the solution had to run on an Android-based internet device, which they had already a heavy investment in, but they also wanted it to run on all the other platforms. So when we started to brainstorm, are we going to deliver 3 different apps? Are we going to write one for each code base? How is it going to look like? And what technologies were we going to use? We started thinking about how we were going to pitch this to them and what technology we were going to use. So the proof of concept, or the first iteration of this app, was built in on Windows Phone. So we had a existing .NET code base. It was about 4 to 6 months of investment there to build it. So we already had this existing .NET code base, and it would be nice to be able to reuse it. The second thing is the customer was very comfortable and reliant on the Microsoft technology stack. So they had .NET developers. They were very comfortable with that stack. So delivering a solution that they were at least familiar with would be comfortable for them. And as I said, we put a lot of effort. The UI did a lot of heavy lifting. And so there was a lot of business logic and functionality, that scanning, the signing, like I said, a lot of business logic that's put into the UI. So there's a lot of room for shared code in that business logic. And so that was one of the points that we thought was key to note. And finally, that BYOD initiative is very important to us and both the business, that each experience felt native to the platform and was easy to use. And Xamarin really ticked all those boxes for us. You have to bear in mind that we started quite a while ago, so Xamarin was very promising, was on the up, and we sort of backed that, and that's why, I guess, some of the reasons as to why we adopted it and went forward with it. So I'll just touch on a little bit when we went through the design process of this new, I guess, second phase of that iteration. So as with everything, the functionality and the scope got much bigger. They wanted to consolidate 3 different solutions that they had on their scanners onto the single app. And this is still has to run on a low-end smartphone as well. It did everything, basically. They did the run sheet creation. They did the onboarding. They did credit card payments, scanning, task management, route optimization. There's so much functionality in this app, so many screens, and we designed each platform to behave as it would on its native experience. So here we can see the Windows Phone solution. Next, this is the Android one. As you can see, it's very Android specific. Same functionality, same UIs, same behavior, same end result, but a different UI based on the Android material design. And finally, we have the iOS version, which as you can see is also adhering to the iOS standards. So I'll just deep dive a little bit further into that. So here's the navigation, for example. We had the navigation on Android. We used the hamburger control. It's very native, very comfortable for Android users. On iOS, I know in the design paradigms, they really hate hamburger controls, and so we use the low tabs at the bottom and native sort of iOS style. And finally, on the Windows Phone, we use the pivot control. So each control is the same functionality, but it's using the native design language. And here we can see some primary actions. So when they actually capture a scan, on Android, we use the fab button or the floating action button. On iOS, we had the nice big scan button. And on Windows, we have the app bar, which once again, each one is sticking to its platform convention. Input fields, you can see each one is applying its own. And pop-up controls. So as we went about designing this thing, and as we were collaborating with the development team, we found a few challenges, and hopefully you find a little bit of insights from this. When we started to try and stray away from the platform convention, the developers started to be, hey, what are you doing? This is going to be a lot harder to implement. And so here's an example. We initially started with this customer rating thing where we used the action sheet on the left, which is standard iOS, but the customer wanted more iconic version of the UI. And so we tried to put these icons inside a pop-up control in iOS. And that looks very trivial from a design perspective, right? But when the developers came to build that, it was a lot more effort than it actually was worth, I suppose. And so we had to redesign it to actually use some native platform convention, and it was much easier to implement. The same thing we had here with this design is we tried to, some of the task management and business logic in the app, where we tried to put too much into an iOS pop-up. Ironically, it seems to be iOS is a common theme here. It's a bit harder to build the UIs. But anyway, so we had to redesign it so it more adheres to what's native on the platform. And I guess, just to wrap that up, essentially, when you're designing and building these native, very native experiences on Xamarin, try to avoid unnecessary customization. That's, I guess, our bit of advice. One of the things that really got us out of strife as well is our design team and our development team work really closely. So the developers always see what the designers are doing and vice versa, and so there's that rich collaboration between the two teams. And a developer doesn't just get a design spec and then he just has to build it, and then you go and see, why is it taking you a week to do a pop-up or whatever it is. So yep, that's my design part, and I'll pass you on to Mahmoud, who will kick into some of the development side of things. Thanks.
Thank you, Arthur. So now we've had a bit of a look at what it's like to design a app for 3 different platforms. Let's take a look at what it's like to develop a cross-platform Xamarin solution. Now, as for me, I've been working with Windows Phone and Windows Store apps for the last 3 years almost. I've got a bit of native Android experience and some iOS native development experience, something that had to come while I was learning Xamarin. But more importantly, I've been part of for over a year now, I've been part of this RMX team, and I've been working using Xamarin and developing for all 3 platforms through Xamarin. So I'll also give you a bit of an overview of what I'm going to be talking about in this part of the session. Now, to start off, as with most things, we didn't know, so we wanted to have a bit of a proof of concept to prove that this can actually be done. And I'll talk about that and some of the things that we learned while doing that. We also, I talk about a bit about cross-platform MVVM, because that happened to be what we did, and I'll talk about some of the caveats with that, and some of the pros and cons of it, and how we did it. And I'll talk about some tools and resources that are available to you if you ever decided to create a Xamarin app. And potentially the highlight of this part of the session, the power of a shared code base. That's one of the biggest features of Xamarin. That's one of the most advertised things, that you can share code. So I'll talk about how that works and whether it's worth it or not. So proof of concept. Now, take a moment to remind you that this initially started off as only a Windows Phone solution. So before we even started considering writing the app for 3 different platforms, so the goal was to rewrite the app and make it work on the other platforms. And if we can reuse code, like I just said, there was a lot of business logic that we could reuse, then why not? It might save us some time. Now, the most obvious option seemed to be Xamarin at the time. We knew that Xamarin can deliver simple applications. We knew that you've got your unique and native UIs for each platform, and we knew that you could share functionality. But the ultimate question for us was, can we take an already existing complex solution and deliver it as such on 3 different platforms using Xamarin? So usually the best way to find out if something is possible or not is to just go ahead and experiment, and that's exactly what we did. We experimented. And we did this mainly for really crucial, essential functions such as barcode scanning and the signature signing. We were a bit skeptical as to whether Xamarin can actually do those on Android and iOS. And at the time, when we started working on this proof of concept, we actually, as a company, we knew a lot of C#, we knew a lot of .NET, but we actually had no experience using Xamarin before. So we had no idea of what kind of limitations there were, what kind of constraints to expect. But now, in hindsight, now we know anything you can do on the native platform, you can actually do through Xamarin. So, as we saw with some of the design challenges earlier, those challenges were not so much Xamarin limitations, but rather they were limitations of the native platform. So we actually implemented a barcode scanner as a proof of concept. And scanning through a camera is quite simple in theory. You open up your camera, you focus on what you're looking at, you take a picture, you analyze that picture, see if there's any barcode in it, and you repeat that until you're successful. Now, while that's simple in theory, it's still a bit of a challenge to keep performance high. Even on what we started with, the low-end Windows Phone devices, with the native C# development, performance was still a challenge. So what we had to do is actually go and research how to make it efficient on each and every platform, because that was a very platform-specific thing. That was using each platform's native hardware, the camera. Now, for example, on iOS, for anyone here who's familiar with iOS development, we had to use something like GPU framework so we get faster filtering and faster barcode extraction. Eventually, we managed to make it work at a very reasonable speed. Now, how many of you here are familiar? How many of you here have actually used Xamarin yourselves? And how many of you here are actually developers? All right, cool. So we've got quite a bit. I'll talk a little bit about what it's like, some of the things that, while we were working on this proof of concept, some of the things that we learned while developing in Xamarin. Now, C# for Android and iOS, the biggest thing you'll notice when you start developing for Xamarin is that learning a programming language, for instance C#, is much easier than learning a programming API. So in other words, just because you can program using C# doesn't mean you can program for iOS or Android. So Xamarin doesn't actually hide any of the platform for you. You still need a bit of a strong knowledge of native Android or iOS development. The only difference is now you're doing it in C#. So essentially, you still see some Objective-C in the way that C# represents iOS. You still see some Java in the way that C# represents Android. So you kind of almost have to be able to read the platform's native code, because APIs are surfaced in a very similar way in C#. And to give you a few examples, for us, we're not doing trivial things with Xamarin. So we wanted highly customized and unique experiences on each platform. So really, you got to know your platform inside out. Now here we can see some Android code both in Java and in C#. And as we can see, this is quite a simple example here, but it gets the point. They're really very similar. So if you are finding a view by ID in Java for Android, you're still finding a view by ID in C#. The only difference is, C# capitalizes its methods, as you can see here. But at the end of the day, you still got your text view from Java Android, and you've still got your resource space that you can get your element names from. Oh, going back. So yeah, and C#, or the guys at Xamarin, they're quite smart with what they do, and they know what we C# developers like. So they also let you do the same thing in a more C# way, which if that's what you're into, then yeah, those are some things, nice features that are available to you. There's another example. So those of you who are coming from a Windows Phone, Windows Store app background, you've got your page events such as on navigated to, on navigating from. In Android, those of you who are familiar with Android development, you've got this. You're probably familiar with this diagram. Whenever you open up the activity life cycle. So an activity is created, it's destroyed, whatever. There are certain events that are triggered. In Java, the onCreate method, for example, when an activity is created, you've got the following. So you're overriding the original, the parent method here. You're calling the base method, which does some magic for you, and then you're setting the content view, which is an XML file. In this case, it's called activity_main. Now on C#, as you can see, it really looks very, very similar. You're still overriding the onCreate method. It's capitalized, but you're still overriding it. You're still calling the base method, and you're still setting the content view. And for the record, I haven't mentioned this yet. For Android in Xamarin, you're still using XML files for the user interface with a C# code behind for the activity. In the case of iOS, you're still using zip files, the XML interface builder, but instead your view controller is now in C#. So yeah, ultimately you can see that you're not really doing anything vastly different with Xamarin. You're really just writing iOS or Android code in C# instead of the native platform. One more example. This is something that really fascinates me. So C# properties, I think they're really amazing, and I think they're using properties is much nicer than having getters and setters. So putting get or set in front of a whole bunch of attribute names and calling them when you want to set something, because it just feels weird setting a variable through a method to me. So, and I'm not talking about just writing your own Android classes in Xamarin with C# properties, but the guys at Xamarin actually did a really nice job of translating originally Java classes, for example, this text view here, surfacing it in C# such that the attributes that you used to use getters and setters for are now actually properties when you're using them in C#. Again, this is for me, I think this is a very, very nice feature, and I'm sure some of you here who are hardcore C# developers think so too. So it's important to know you're not getting any new attributes. Your text view doesn't all of a sudden have a flying mode or anything. You still got your original attributes. You're just the way you access them is slightly different. Now, native bugs. Xamarin, like I said, doesn't hide the platform from you. It brings it over, and it brings it over in such a way that it brings both the good and the bad. And what I mean by this is, while we were working on that proof of concept, we noticed that a particular phone couldn't continually autofocus the camera. So we had to find a way to get around that by manually asking it for a focus every second or so. Now, thing is, that was something that happened on the native platform. When I was researching why on earth is it not continually autofocusing, it just happened to be that there was a bug on that phone, on that version of Android. And that's something that Xamarin brings over to you. So it's not Xamarin's job to fix native bugs. And I think that's very interesting that it almost mirrors, it does mirror what's going on when you're doing native development. So I think that's something very, very interesting. So that was kind of our proof of concept. Those are some of the things that we learned while making that proof of concept. And once we were confident that we could deliver these essential functions and we could deliver the full experience, we knew it was time to get to work. So cross-platform MVVM. Of course, as you know, whenever you start up a new project, you're thinking about, okay, what kind of architecture are we going to use? How are we going to set up the project and whatnot? For us, it was more of a question, what can we do with our existing one? Now, MVVM is very common in C# and XAML projects. Usually, it's the smart choice, but you got to keep in mind future possibilities. You never know when you might have to port your app into other platforms. Now, it's very common in C# XAML projects, but for us, we initially started off with our Windows Phone solution. We used Xamarin Micro as a framework to help us get some of the MVVM things done. Now, when we transitioned to Xamarin to make a cross-platform app, Xamarin Micro just didn't support iOS or Android because it just wasn't made for those platforms. So we started thinking, okay, so what can we do with this? Because we already had a whole bunch of view models, a whole bunch of MVVM kind of structure going on there. We happened to find this thing called MVVM Cross. Now, this presentation is not about MVVM Cross, but it's still something that I really want to share with you. It's still something quite interesting. So swapping out a framework is no simple task. And we went through and we ripped out Xamarin Micro, we chucked in MVVM Cross. And that meant for the original Windows Phone solution at the time, we had to do a lot of testing. We had to make sure no stone was left unturned because things, we wanted to make sure things still held together. On the other hand, we only just started working on Android and iOS. Now, MVVM Cross comes with pretty strong libraries to do some platform-specific things. So things like file storage, your user settings, your location settings, and some things like that. These are things that can be written by you, but it's still very handy that they kind of come already ready with the MVVM Cross framework. Now, and through that, it gives you the illusion of a bit more shared code. So whether you're using MVVM Cross or Xamarin Micro or something else, MVVM is really still MVVM. And we know MVVM works quite good for Windows Phone or Windows Store app, or rather C# XAML projects. But how does it work? Does it still work so good on Android or iOS? Now, again, you're still using XML files for Android, and you're using the XML interface builder for iOS. So typically speaking, because you have access to the code in Android with the XML, it kind of looks like XAML. And in general, Android is a bit more amenable to the MVVM style than iOS. Now, in saying that, iOS needs a bit more MVVM glue to actually make MVVM work on that platform. So for, if I'm going to recommend anything for a better iOS development experience, you're probably better off doing it in the way that the platform expects you to do it. So not even that, just that, probably iOS performance is better in non-MVVM projects, given the cases where you have to apply a lot of MVVM glue. So if you try to force it, there are consequences to anything. So just a brief reminder that for each platform, you got to be aware of when things are called. You got to be aware of when it's an appropriate time to call things. And you really need to know your platform inside out and how the gears work in that platform. Now, it's not uncommon, with Windows Phone's future, it's not uncommon that people will start considering using Xamarin for Android and iOS only. And in fact, we actually do have a project in the pipeline where we have a client, they want an Android iOS solution, and we've decided that Xamarin is a good thing here, and we want to share code and whatnot. I've actually met some people in this conference who will swear by it. In fact, they will develop an iOS-only solution, not even making use of the whole shared code thing, but they'll use it for iOS only just to get away from Objective-C. And personally, I don't blame them in this case. So yeah, I think Xamarin is very valid if you wanted it to if we wanted to use it for iOS or Android, or just one of those platforms. Now, luckily, Xamarin comes with a lot of tools and resources that are available. There's a wealth of things out there. And one of the things that, as a developer, one of the things that are most important to you on a day-to-day basis is your workspace, your IDE, if you will. Now, using Xamarin, if you're on a Windows machine, you're most likely going to be using Visual Studio. On a Mac, you're going to be using Xamarin Studio. And before I start talking about any of these tools and our experience with them, it's very important to mention that the experience has vastly improved since, we've noticed vast improvements since we started working on it. And, some of the things up there, IntelliSense, UI designers, compilers, whatever. In short, what I'm trying to say is whatever experience you had, whatever great experience you had developing Windows Phone and Windows Store apps through Visual Studio, you'd want that exact same experience when you're developing for iOS or Android. You don't want it to be lacking in any way or shape or form. Now, for all intended purposes, I can verify that Visual Studio can, in fact, get the job done for all three platforms. In saying that, you still need remote access to a Mac if you wanted to do iOS development. I don't blame Visual Studio for this, but it's a thing. The Visual Studio Android Designer, I have used it a few times. It works. I don't think it's as robust as the one that's available in Android Studio, which, kind of fair enough. And in my case, I personally like to write up my XML files and, instead of using any kind of, interface builder or designers. So what I'll typically do when I'm working is I'll have an instance of Android Studio running. I'll write up all my user interface files there, all my XML. And then once I'm happy with it, once it previews quite nicely, I'll copy that over into Visual Studio. And that works, and maybe in the future, the Android Designer in Visual Studio improves, and maybe I won't need to do that anymore. The iOS Designer, on the other hand, it is a bit of a nightmare in Visual Studio. You're probably not writing code for iOS UI files. You're probably using the interface builder. And what tends to happen here is because you're remoting into a Mac to be able to actually use the designer, the Visual Studio tends to hang quite a bit here. And for you as a developer, you're working on something, you're in the zone, you're moving, and all of a sudden, you've got that 1 minute, 2 minute hang, and you're pulling your hair out. Well, we might have already lost a few developers over that. So I'm not going to compare the iOS Designer in Visual Studio to Xcode because we're still on a Windows machine, as far as this slide is concerned. Now, in conclusion, what I'm trying to say here is you probably want to try avoid developing for iOS on a Windows machine to begin with, because the bridge just seems to crumble quite often. Me personally, unless I need to do major changes though, I will still use Visual Studio. It still does get the job done. And that's mostly because, if I'm being diplomatic here, Macs are very foreign to me. So, Xamarin Studio. If you're doing iOS development with Xamarin, you're better off doing it on a Mac, and you're probably going to be using Xamarin Studio in this case. It's much more responsive. For iOS, it's much more responsive than Visual Studio. You can still do Android development through Xamarin Studio. You still have to use a Windows machine for Windows Phone, so one for one. Although the UI tooling in Xamarin Studio for iOS still, again, is not as good as the native IDE, for example, Xcode, or maybe there's something else. And what I mean by this is, it can sometimes be a bit inaccurate when you're putting stuff on the screen, or it doesn't give you the full flexibility that you want. Sometimes, when moving a button over to another place, it doesn't refresh, and all of a sudden you've got two buttons on the screen, things like that. So the end result is, developing for these platforms. I tend to either end up writing a lot of XML code in Android Studio, or using Xcode, which is a thing. You can open up your Xamarin interface files in Xcode and do your changes there, and that tends to get the job done for us. Now, as complexity goes up, so for simple applications, for our proof of concept, it was all good. We had no problems with the designers in each of these IDEs. But once your app starts getting bigger and more complex, the tooling does start to creak a little bit. And I think this is something that we can expect major improvements in the future. Now, I've got here platform-specific debugging. And I'm not talking about debugging shared code or business logic or any of that, because I'll get to that in a moment. But here I'm just talking about debugging the user interfaces, so your activities or your view controllers and so on. Usually it's quite well. usually, you've got some sort of indication of what you've done wrong, but at times, you will get some inscrutable errors. You will get some cryptic exception messages. For example, in iOS, if you've, one of your zip files is missing a necessary component, you'll get an out of range exception. And you'll be looking for your list that is out of range, and you're not going to find it because that's not actually what's going on. But luckily, there are common cases where you see these kind of things, and there are people who will tell you that actually you're missing something or the other. There are times when it's happy. There are times when it's not. I could say the same about myself. But all in all, platform-specific debugging works good for the most part. Documentation, there are plenty of Xamarin resources out there. So in saying that, your Xamarin Android resources aren't going to be as much as your native Android resources by Google or the iOS ones by Apple. However, because of the way the platforms are surfaced in C#, you can still actually use the native documentation. So you've got your Microsoft Dev docs, your Android docs, and so on. Because chances are, if you're on Google and or Bing, sorry, and you're searching for how to do something in iOS, chances are you're going to find the answer written in Objective-C or Swift or something like that. Now the cool thing is, because you're using very similar or you're using the same APIs just in C#, you can actually go through those resources and actually translate Objective-C or Java into C#. But that reinforces the point that you need to have some knowledge of the native platform, and so that you can port those actually into C#. But it works quite well, and it's been very handy for us. So not only do you have the Xamarin resources, but you've also got the native ones for whatever you're doing. Now, all the good stuff, all the necessary stuff in terms of libraries and tools, those things are made available to you by Xamarin. So if we take a look at Android, all of your Google support libraries, all of your Android compats, they're made available to you by Xamarin. They're only available to you, however, they're only available to you as soon as Xamarin makes them available. So what this means is, you've got a new version of Android. It can sometimes, take I think recently it's become quite fast, maybe around the 30-day mark. In the past, it might have taken a bit more. For us, this hasn't been a problem. So I'm commenting about it, but it hasn't been a problem. I have heard some people complaining that it takes months for them to get it done, but usually it's been quite fine for us. So another very interesting thing is here. So apart from operating system updates for each platform, you've got a lot of native libraries. So you've got your jar files thrown out there, and in our case, as Etta mentioned, RMX had already a big investment in these Intramec devices, and those devices are ruggedized scanners, so they actually do have an infrared scanner head attached to them. And we talked about how we did camera scanning, but it makes no sense for us to do camera scanning on a machine like this, even though it does have a camera, but it's also got a scan head. So when these devices are shipped, they come with a jar file that exposes that functionality, so you can actually use the scan head, scan a barcode, get the data, and do something with it. But we don't have jar files in .NET. However, the Xamarin tooling does a very good job of letting you basically wrap that jar in a DLL. And that functionality is exposed to you in a very similar way to how the platform is exposed to you. So your attributes in that jar file are, well, your getters and setters are all of a sudden properties, and things are mapped in a very similar way as I was showing you. And that's when the tooling comes in very handy here. So we were actually able to deliver a Xamarin solution that uses the infrared scanner attached to these ruggedized devices. So what I was talking about earlier, what is potentially the highlight of this part of the session here. Now, we all know that C# is a great programming language, but that's not the only highlight of Xamarin. And for us, we wanted to reuse a lot of the business logic code that we had. And this is kind of what we expected. So according to the Xamarin website, code sharing is usually around the 75% mark, and you've got your platform-specific stuff at around 25%. So there are other frameworks out there that will let you share 100% code, depending on how simple your app is. There's a reason we didn't use those. We still wanted our very native, very unique-looking user interfaces for each platform, our very the whole hamburger control on one and then the pivot control on another. And we didn't think that that was possible at the time using some of these 100% code sharing frameworks, including Xamarin Forms. And I'm happy to be corrected here. Maybe the whole custom renderer stuff can get the job done. But again, we thought this was the best way to go, the cleanest way to set up our projects and whatnot. And the performance of Xamarin Native is ultimately, as we've seen in a previous session in this conference actually, there's vast differences between the performance of Xamarin Native compared to Xamarin Forms, even on simple apps. So that's our typical workflow and probably common across many companies. And because of the way we use Xamarin, we ended up doing a lot of shared development, that things that will happen on all the platforms, and a lot of shared testing. And that's the stuff that you can see in red. And we'll go into detail as to why we shared those and why we intentionally did not share the UI in a later section. So what you can share. A lot. So all of your web services, all of your business logic, navigation logic, view models, those are all things that you can share. You only have to write once for each platform. It's only when you put something on the screen that it becomes platform specific. And that, for us and for RMX, that was a huge win. There were lots of screens, lots of logic in each screen. Then that meant a lot of code that did not have to be rewritten, a lot of code that did not have to be maintained again. And when developing, usually we start off with the shared code. We think about our view models, what web services we need. If we needed to check those out in a user interface, for us, we'd usually use Windows Phone first. And that was because it was the native, the C# to begin with. And once we're happy with that, we'll usually move on to the other platforms. And sometimes we'll have to adjust some of our view models slightly. Now, shared debugging and testing. This is something that we think is really amazing. So I'm a developer. I'm working on a feature. I finished that feature, or I think I finished that feature. I give it off to the testers. Testers come back to me all of a sudden, and they say, "Hey, your calculation here, or the sum of all the cash payments for these deliveries is actually wrong, or you missed something, or missed a collection, or something." So I go and I think, okay, this doesn't really sound like a UI problem. So I go dig through the shared code. I fix it on Windows Phone. But actually, I also fixed it on Android and iOS at the same time. That's something I think is amazing. The fact that you can fix it in one place, you don't have to worry about it in the other platforms. So really, for platform-specific things, you just got to make sure that the user interface reacts correctly. But if you know that this is a shared problem, all of a sudden you fixed it once, you fix it everywhere. And sharing unit tests, because really, who wants to write the same unit test 3 times on 3 different platforms in 3 different languages? Please raise your hand if you do, and come see me afterwards. We'll get you checked. So shared testing, shared unit tests for business logic and view models is quite easy. You've got all your mock objects and dependency injection and whatnot, and very handy, very useful, and again, platform-specific things. Just make sure the UI reacts correctly, and for that, whether you're designing or developing a cross-platform app, you got to know your platform inside out. So what can't you share? And really, I think I can sum this up and say you can't share with what we're using here, Xamarin Native. You can't share anything UI or that's a platform-specific service from whichever OS that you're developing for. So UI elements, they don't cross over. If you're coming from a Windows Phone background, you've got your text box. You don't have that text box on Android or iOS, so you've got your text views and UI labels and so on. At the end of the day, with Xamarin, you can't, not Xamarin Forms, but with Xamarin Native, you can't share user interfaces if you wanted a unique look on each platform. And again, yeah, there's a reason that we went for what we did because we wanted to keep performance somewhat high and to actually deliver a unique and native and meaningful experience on each platform. So if we look up here for a bit, that's a courier driver wants to start their day. They've got a list of tasks that they want to take care of, a whole bunch of deliveries and collections and whatnot. Now, whether they had an Android phone or an iOS phone, the list of tasks is always the same. The content is shared, and that's stuff that you, for the most part, on a platform-specific part of the project, you just have to surface it in the right way. So if you're doing it on Windows Phone, you might be using an items control. On the other hand, on Android, you might be using a list view, or in our case, an MVX list view, which is available to you by MVVM Cross. It's amazing. Now, while you can share content, that also means you can share things like enabled states. You can share things like visibility states. You can even share the colors of things. As long as you have a proper converter on each one of those platforms, those are all bits of content that you can share to your platform. The UI elements themselves are not shared, so your button on Windows Phone is, you can't use that on iOS, and so on. Now, there's also OS services or platform-specific services. So one of the things that we wanted to do on Android is that when a courier starts their day, we wanted them to turn their location tracking on, because Aramex wanted to keep track of where a courier was at a particular time. Now, when you're doing this on Android, you can actually use some Google service, some Google library, to actually show a dialog and let the user turn on their location tracking from there. You can't do that on Windows Phone. The best you can do is make up for it using something like a dialog message saying, hey, please go to your settings and turn on location tracking. But you can do that with Android, and those are, again, examples of things that you can't share. This next part is important. So again, I repeat, we wanted to share code. We wanted to save time. How much code did we actually share? And this is what our project looks like. And for the record, these numbers, they're based on lines of code. And we're excluding unit tests because if so, that would mean the shared stuff would be much bigger. Now, what you can see here is a whole bunch of shared code, a whole bunch of shared projects. On the other hand, you've got 3 individual platform-specific projects as such. And this isn't as impressive. This would be much more impressive if we actually looked at each platform individually. So let's take a look at Windows Phone, for example. What's going on here is 78% of the Windows Phone project is actually code that's being used somewhere else. We only 22% of that project is Windows Phone specific. Now, on the other hand, if we look at iOS, for example, we can see there's a lot less shared code in that. That's the same shared code that's in Android or Windows Phone, but there's more percentage of user interface code in that, most likely because of all of that MVVM glue we had to apply, and maybe iOS just needs, it takes up more lines of code when you're developing a user interface on it. So again, this is just to show that we had a native user interface for each one of these platforms. If you were to go ahead and install the app on your phone, there would be no way for you to tell that this was a Xamarin. This was developed through Xamarin. These apps, they look very native. And while we speak here, there are thousands, if not tens of thousands, of courier drivers out there delivering their packages, doing their task management, picking up packages, whatnot, using this cross-platform Xamarin solution, whether they've got a Windows Phone, Android phone, or an iPhone. Now, another thing here is you can see roughly on any given individual project, it's around 60 to 70% for us on average of shared code. What this means is if Aramex all of a sudden decided to make an iPad app, 60 to 70% of that iPad app is already finished. Now, this isn't something that's advertised by Xamarin. We're not being paid by Microsoft to say this, but this is actually something that we're very grateful for, that we're very thankful for, because it's real. This is something that this is code that we were able to share. This is code that helped us save a lot of time as a business. Saving time and resources is a very big deal. So some of the key takeaways from this talk. we have proven, and we are very confident in the fact that Xamarin can deliver complex applications. And while doing that, you still, if you ever decided to develop for Xamarin, you still need a very strong knowledge of the native platform. Whether you're designing for it or developing for it, you need to know your platform inside out. Remember that Xamarin does, in fact, let you share a significant portion of the code. And in doing that, Xamarin does help you save time. So please rate our session. We would love to get your feedback and see what we can improve. And if you wanted to get in touch with us, you can get in touch with us through the following. That was our journey delivering complex cross-platform Xamarin apps. And we have a bit of time for questions. Thank you for watching.
Did you manage to get any kind of continuous integration process going with a build if you repeatedly build the output of all three solutions, like QA and stuff, like getting MS build stuff to produce these outputs?
Yep, so we've got DevOps fully integrated with what we're doing, and Visual Studio takes care of that very nicely. Now, I'm not the one who set it up, but we still get the artifact and the drops of Android and iOS. For Mac, the iOS solution, we still have to use a build server on the Mac, but we can still do that very well. Please.
You mentioned dependency injection. What framework are you using for that?
So we're using inversion of control here, and MVVM Cross actually does provide you with the full support to register all of your interfaces and resolve the concrete classes of those.
For the backend, IOC?
The backend of the services and whatnot.
Yeah.
We don't take care of that. That's so all of the web services, the endpoints rather, if that's what you're asking about.
Like the business logic of your app.
Yep.
So your web client, whatever.
So we've got some shared interfaces and shared concrete implementations, but then we've also got the platform-specific ones.
Yeah.
So what we do is we have a shared interface and then the concrete implementation of which on each platform. So when I was saying something about the illusion of shared code is, let's say you had a process such as your user wanted to log out, or in this case a courier driver. They had a whole bunch of tasks for the day. They haven't finished those tasks. So you want to ask them, are you sure you want to log out? You've got some unfinished tasks. Now, how do you balance between what's shared and what's platform specific is, if user has unfinished tasks, ask the user something. Now, this is done through an interface, which is, there's a concrete implementation of that on each platform, which then takes care of, you ask for that concrete implementation of whichever platform, and then that surfaces up a message that you can get some response back from, if that answers your question. Please.
Follow up his question. You're using the MVVM cross plugin architecture rather than the Xamarin one?
Sure.
And he was asking about DI because MVVM cross has got its own code base for DI containers, which is relatively simplistic, and you can switch out and put a Ninja or whatever DI platform you're more favoured in, as much as generally you can get a little bit more performance. It's kind of whether or not performance is an issue.
All right. Right.
So you're just running with the MVVM default DI.
Yeah. So again, I repeat that this is our first time delivering a cross-platform Xamarin solution, and I'm very happy to actually take that feedback back to the team and see what we can do about it. Yeah, it's just something that we kind of set up in place, and we used it. We haven't had, I don't recall having major issues with it. So some other things, we do a few other fixes to get around it. But yeah.
I actually tried switching out and using some alternate DI containers just to prove that the capability worked okay, but I never actually found much speed advantage. So I just went back to letting the default do it.
All right.
But it's kind of like if you've got an application that's doing a lot of
Heavy lifting or
registering and resolving of classes and creating a lot of stuff on the fly, it might give you a slight performance boost. That might be important. But apparently earlier in the conference and some other sessions, they were saying that people still talking about Xamarin not being as quick as native. Is that something, did you actually do any speed trials of the Xamarin wrappers versus the real native to get a feel for, because to me, whether or not it's true, it's still only a relatively small percentage, and the gain in Xamarin kind of fast outweighs a few percent of performance.
So the question is whether the Xamarin performance how does Xamarin performance compare to native performance? And yes, in fact, native apps will give you better performance. But is that going to stop you from actually using Xamarin? And ultimately, that's up to you and up to how you set up your project. There are some things you can do to improve performance, but yes, it won't be as good as the native platform. But where it lacks in some areas, it highly benefits you in some others. So you got to see what works best for you.
We haven't experienced any